Hello everybody, we are Alex, Ivan and me, Eric. We're going to present an experimental bribery game, a research paper by Klaus Abing, Bernd Irlenbusch and Elke Renner. Our agenda is the following. We'll start with an introduction, then we'll present the experimental design and the experimental procedure, present you the hypothesis, talk about the results of the research paper, have this short sequence talking about research versus reality, and finish which is based on a true story. While watching it, I'd like you to try to identify the three characteristics of corruption.
O senhor tem conhecimento de um esquema para lavagem de dinheiro e corrupção de agentes públicos?
Não.
Tem conhecimento de um consórcio de empreiteiras que tinham privilégios?
Não.
De onde vem esse dinheiro?
Exatamente o que eu tô querendo descobrir. Eu não sou chefe do esquema. Tem gente bem maior, né?
E o que o senhor quer dizer com gente maior?
Tudo bem, presidente?
Muito maior do que a gente podia sonhar.
Essa história vai desdobrar.
A gente só tá querendo uma trégua, é isso?
Quem iria imaginar que uma casa de câmbio fureca em cima de uma lava-jato movimentava os recursos da campanha presidencial mais rica da história desse país?
Vai rodar todo mundo.
We'll talk about the characteristics of corruption very soon. I will briefly introduce the authors of this research paper. Since 2019, Klaus Abing is a professor at Monash University, Australia, and also the director at the university's Center for Development Economics and Sustainability. At the time the research paper was published, he was employed at the Bonn University together with Bernd Irlenbusch, the second author of this paper. He is currently a professor at the University of Cologne and the principal investigator of the research group Design and Behavior at Deutsche Forschungsgemeinschaft. Last but not least, Elke Renner is an associate professor at Nottingham University. Creating this research paper, she was a junior researcher at Otto Beisheim Graduate School of Management in Koblenz. In 2000, the three of them also published a research paper in the Journal of Economic Behavior and Organization called The Moonlight Game, an experimental study on reciprocity and retribution. To understand why this research was conducted, we will look at earlier research on corruption. Paulo Mauro investigated the effects of corruption on economic growth. Michael D. Long and Spuma Rao found that a company's value drops significantly after its manager's corrupt behavior has become public. Caroline van Rijkheim and Beatrice Weder proved that corruption occurs less often when wages of public officials are relatively high to those in manufacturing. A positive correlation between the corruption level and the income equality in a country was found by Sanjeev Gupta, Hamid Dawoodi, and Rosa Alonso Terme. As we see, these research papers help to understand the socio-economic implications of corruption with empirical data. Right now, you will see whether your take on corruption's characteristics was correct. The three main characteristics of corruption are: first, the basis for all corrupt acts is reciprocity. Firms and public officials exchange benefits and build a relationship that relies on trust and personal gains, since they cannot rely on a legal contract, shown for example by this screenshot of the conference-like meeting with the president. Second, corruption always has the consequence of negative externalities to the public. Both in the series and the reality, you can see this occurring very often in Brazil. Third, since corruption is a crime and therefore punishable, we define the last characteristic, the risk of prosecution. shown, for example, in the screenshot with the federal policeman and what turned out to be persons involved in the scheme. Those characteristics are presented in the experiment by the following 3 stages. In the first stage, we only have a simple money transfer between briber and bribee. The researchers wanted to observe the impact of reciprocity and trust in the stage. In the second stage, we observe social welfare considerations of the participants, and the subjects did the treatment with the same elements of the first stage, with the addition of negative externalities to other players. The last stage added a sudden death with low probability to study the effects of a penalty. The behavior of the participants is given by the assumption of utility maximization. Now, Ivan is going to present the experimental design.
And now we are coming to the model of the experimental bribery game. In the experimental bribery game, single pairs, each one with 2 players, participate. The first player is a potential briber, also called as a firm or user, and the second player is a public official. In this game, a potential briber makes a proposal to the public official and hopes that the public official will later make a decision in favor of the briber. So, first, the briber transfers a certain amount of money to the public official. After that, the public official can accept or reject this money, and finally, the public official can make a decision in favor of the briber or not. This game can be considered as a situation in which a briber asks a public official for permission to do something illegally, and the public official decides whether she allows it or not. Altogether, there are 3 different treatments in the experimental bribery games. The first treatment is called pure reciprocity. Here, it is just a console treatment. And the second treatment is a negative externalities. It has the same structure as pure reciprocity treatment, but now damage to other players is introduced whenever the single pair behaves corruptly. This allows us to separate social welfare considerations when comparing this treatment to the pure reciprocity one. And finally, we have the sudden death treatment. This one has the same structure as negative externalities treatment, but now corruption can be discovered and punished. So all the 3 treatments allow us to separate different effects, such as social welfare consideration and risk preferences. Each treatment is played 30 times subsequently by each pair of the 2 players, and together there are 9 pairs in each treatment. Now we are coming to the structure of the pure reciprocity treatment. It is a sequential game with 2 stages. At the first stage, the potential briber, such as a firm or a user, makes a transfer, and the transfer can range from 0 to 9. It cannot be negative, and only integer transfers are considered here. So, if the transfer is a positive number, so it is more than 0, the potential briber must pay a small fee of 2, and it actually doesn't matter whether the public official rejects or accepts the bribe. Then, the public official can accept or reject the bribe. If she accepts the money, she receives the tripled amount, and the idea is that there are differences in marginal utilities between the public official and the potential briber. For example, the potential briber can be a firm and a large firm, and this money matters far less for a large firm than for the public official. And if the public official rejects the money, both accounts remain unchanged, but only the small fee is paid by the briber if he tried to transfer a positive amount of money. At the second stage, only a public official makes a decision between the 2 alternatives, as they denoted here as Y and X. For this stage, it actually doesn't matter what happens at the first stage. So the public official always makes a decision between the 2 alternatives at the second stage, regardless of amount of money the briber tried to transfer and the decision of the public official at the first stage. According to parameter constellation set by the authors in this game, if the public official chooses an option Y, which is in favor to the briber, then the public official gets utility of 30 and the briber yields utility of 56. We can imagine that in this case, the public official permits the briber to undertake illegal activity, and this illegal activity increases briber's profits dramatically. And if the public official chooses an option X, which is not in favor for the briber, both players yield utility of 56. The idea is that an option X is more preferable for the public official as she doesn't need to justify her decision before her supervisors and make a further effort to get the permission for the briber in this case. Now we come to the negative externality treatment. Basically, it has same status as pure reciprocity treatment, but now other players are damaged whenever a pair chooses an option Y. We have 9 pairs in the experiment, altogether 18 players, and all the pairs play simultaneously. So whenever an option Y is chosen by the pair, all the other players are damaged by 3 per round. Total damages induced by only one pair is then 48, since 16 players are damaged by 3. If all the 9 pairs choose an option Y, each player is damaged then by 24 per round. Interestingly, an option Y is overall inefficient because damage exceeds motional gains from corruption if all the pairs choose an option Y. We have an example here. Suppose we have a single pair, the briber makes a transfer of 9 and the public official chooses an option Y. Also, all the other public officials choose an option Y. In this case, the briber gets utility of 21, which is smaller than 36, and the public official yields utility of 33, which is also smaller than 36. So this outcome is inefficient in the sense that all players could have yielded more utility if nobody behaved corruptly. But if nobody behaves corruptly, it is always an incentive to deviate to corrupt behavior. Also, it is well known that bribery is carried out secretly. In this game, no feedback was provided to other players after the round. That means players didn't know whether other players behaved corruptly and to what extent players were damaged by others. So players didn't know about their payoffs during the game. Finally, we have the sudden death treatment. It has the same structure as negative externalities treatment, but now there is a possibility to be discovered whenever a positive amount of money is accepted by the public official. So here we have an exogenous lottery called sudden death, and it is played to determine whether corrupt behavior is discovered in the single pair or not. So this lottery is played in each round in which a positive transfer of money is accepted by the public official. And in case of discovery, both players are disqualified from the experiment. That means that they lose all their previous earnings and they cannot participate in later rounds. And the sudden death treatment illustrates the real life so that agents face the end of their current careers in case of the discovery. And the probability of the sudden death is here 0.3%. And we have formula for the overall probability of sudden death. And for example, if the corrupt behavior is observed in all the 30 rounds in the single pair, then the overall sudden death probability is 8.6%. We can see here a game theory of sudden death treatment in a single round, so we can analyze game theoretic equilibrium of this game. The briber is denoted here as U and the public official as P. The hangman pictogram shows sudden death, and the exclamation mark 3 at the bottom says that other players are damaged by 3 due to a Y choice. This game tree is actually incomplete because players don't know to what extent they are damaged by others, so they don't know their payoffs after a single round. Interestingly, an equilibrium of this game tree is the one in which a public official chooses an option X and the briber doesn't transfer money. For the public official, it's not profitable to choose an option Y, as option X gives her more utility. The briber anticipates this behavior and doesn't transfer money because the public official will still choose an option X. So the game theoretic equilibrium yields a non-corrupt outcome. However, this simple profit maximization described in the tree omits a probability of reciprocal behavior. So let's examine reciprocal behavior and its possible gains. Suppose we have an overall probability of sudden death equal to 8.6%, which means that the single pair behaves corruptly in all the 30 rounds. We can denote small x as a total payoff for a player per round by playing equilibrium strategy, and small y as an additional payoff that can be gained for a player if the reciprocal behavior is chosen by both players in the pair. We can assume that all the players are risk neutral. Here we have an inequality, and if it holds, it is profitable for both players to choose a reciprocal strategy. On the left-hand side, we have an expected value of the equilibrium payoff plus additional payoff. On the right-hand side, we have only a total equilibrium payoff. So the left-hand side must be higher than the right-hand side to make reciprocal behavior more attractive for the players. We can rewrite this and get the following result. The ratio between y and x must be 9.4%. That means that the gain must have a relative share of x at least 9.4% to make reciprocal behavior more attractive. We can visualize by the two examples. Suppose we have two possible payoffs for the bribe and for the public official. The first payoff, if an option X is played and transfer is 0. In this case, each player gets utility from 12 to 36, depending on damage induced by other players. The second possible payoff is if the briber transfers an amount of 6, for example, and the public official chooses an option Y. In this case, each player have a payoff from 24 to 48. So the additional payoff, small y, is then 12 in all the possible cases if minor transfer is 6. However, the ratio between small y and small x has a range of 33.33% if small x is 36 to 100% if small x is 12. We can see that reciprocal behavior is profitable here for both players if they are risk neutral. Let's have a look at the experimental procedure. The experiment was conducted at the University of Bonn. The subjects were encouraged to participate through the posters in campus. There were various disciplines at the university. However, the largest fractions were law and economics students. The experiment was designed in context-free fashion to minimize the framing effect. Participants were called as player 1 and player 2 and not as a briber or a public official, and the money transfer was just a money transfer but not a bribe. The experimental session took about 90 minutes per each treatment, and each participant received a show-up fee of 5 Deutsche Mark. This ensured that disqualified subjects remained sitting till the end of the experiment. Altogether, 2 sessions, each one with 3 treatments, were conducted. In each treatment, 18 players played in 30 rounds, and the player's final payoff was cumulative, so that each single round was important. The total earning during the session had an average of about 17 euros, which is far more than students' regular per hour wage.
Now we're comparing the hypothesis with the numbers we're getting out of the study. So, clear to see, the level of corruption is manifested by the amount of offered bribes and the times the public official chose Y. Also, the impact of a relationship over the sequences is decisive, as it is seen when a public official is constantly receiving money. In exchange, he rewards the firm. So, to manifest the experiment, the authors brought up 4 hypotheses, which I shortly will present to you and explain. And afterwards, I'll come to the results. So, let's start with the first hypothesis. Firms tend to transfer substantial positive amounts, which is reciprocated by the public official's choice of Y. This effect is particularly strong in the PR treatment. So what does this hypothesis mean? It means that the willingness to act in favor of the one you're benefiting from is very strong, and so that the benefiting and the trust can build up a corrupt relation. Second hypothesis is, in the negative externality treatment, public officials tend to choose Y less frequently, and users tend to transfer less than in the pure reciprocity treatment. So that means by considering the impact others are receiving, people tend to lower their rate of bribes, especially the public official who is in charge of the trade. is put in a moral dilemma. The third hypothesis is in the sudden death treatment, public officials tend to choose Y less frequently and users tend to transfer less than in the negative externality treatment. So here it's clear to see that the authors favorize the third treatment, sudden death. Okay, so the third hypothesis. In the sudden death treatment, public officials tend to choose Y less frequently and users tend to transfer less than in the negative externality treatment. So here it's clear to see that the authors favorize the sudden death treatment as the most efficient one. And last but not least, the fourth hypothesis. The subjects tend to underestimate the total probabilities of being disqualified in a whole session for given single round probabilities and round numbers. Here we have a reference study by Kirchgessner in 1997, who stated that people involved in real-life corruption have a wrong calibration of the discovery probability. So that means that they're putting their single action out of context, because the overall penalty is much more significant than the additional gain by a single bribe. Now we're comparing the hypothesis with the numbers we're getting out of this study. So clear to see, the level of corruption is manifested by the amount of offered bribes and the times the public official chose Y. Also, the impact of a relationship over the sequences is decisive, as it is seen when a public official is constantly receiving money. In exchange, he rewards the firm. And when a public official chose Y, the firms are penalizing it by a lower amount transferred, which is also represented by a significant positive Spearman rank correlation coefficient in each treatment. For the pure reciprocity treatment, it's 0.87. For the negative externality treatment, it's 0.94. And the sudden death treatment, it's 0.93. That makes the first hypothesis fulfilled. We are now comparing the distribution of bribe offers and the frequency of Y choices from the first two treatments. We can see that they are very similar, both in their absolute terms and in their evolution over time. Here in the graph, also with their averages. That makes second hypothesis not confirmed. What's also interesting is to have a look at the evolution of averaged offered transfers and the averaged Y choices frequency. First, they start low in average, while the trust between the firm and the public official is rising. Then, from round 12-13, they rise to a certain level and move less volatile. And in the last rounds in all three treatments, the results went lower, which can be explained by the circumstances sitting in an experiment and not taking it that serious anymore by the time the sequence is finishing. Coming to the third hypothesis, on the ST treatment, the firms transferred 35% less and the average frequency of Y choices drops by 43.8%. With the graph on the left side, it is obvious, even when high amounts from 8 or 9 got transferred, there were much higher probability that the public official will reject it. With the threat of a drastic penalty, even with a low probability, the participants tend to lower their bribes and the reciprocal effect is much lower. Also, part of the study was a questionnaire which the participants had to fill out after the sequence. They should rate the probability of being caught. Here on the right graph, on the x-axis you have the probability and the number of rounds, and on the y-axis you can see the probability of disqualification. You can see a big difference between the estimated answers and the actual results. The participants rating the probability of a penalty in all categories very low, relative to the correct answers, which fulfills the fourth hypothesis and links up with Kirchgessner's results. I think it's interesting that the underestimation is in contrast to the lower transfer and the lower Y choices. So this strengthens the result that the fear of a drastic penalty has a strong effect on corrupt behavior. Now, with the fourth hypothesis confirmed, I'm passing on to Eric with the conclusion.
Now I will conclude the research paper. There are three characteristics of a bribery: reciprocity, negative externalities, and the risk of a penalty. The results were the following. In the PR treatment, Trust and reciprocation can establish a stable exchange of benefits, with both subjects conditioning their decisions on the previous decisions of the other one. For the NE treatment, the results for both transfers and decisions show striking similarities to the PR treatment. For the SD treatment, it saw a strong reduction on average transfers, Y decisions, and a raise in transfer rejection. Furthermore, the subjects underestimate the risk of prosecutions, just like in the thesis of Kirchgessner. As a conclusion for public officials designing anti-corruption campaigns, the authors advise to stress the risk of prosecution instead of the harm for the public. Now Alex is going to present a small part about research versus reality.
So, it is also important to light up limitations by this study. First of all, the participants were most likely economics or law students, which are participating in an experiment because of the monetary stimulation. We don't know much about their background or behavior. So, what is the subject of the study? The different impacts of negative externalities, drastic penalties, and pure reciprocity are considered. Sure, in real life, it's not that just one treatment is in use, but here we discovered the sudden death treatment has the most influence in the firm's choice of a transfer and the public official to return in favor of choosing Y. In the next slide, you'll find our references, and then we're finished. Hope you enjoyed our presentation. Thank you for your attention.